In a region, there exists a magnetic field B naught along positive x-axis. So here the magnetic field is B naught along the positive x-axis. A metallic wire of length 2a, here it is the metallic wire PQR. It is of length 2a, one side along x-axis and the other side is along y-axis. Is rotating about y-axis. Okay, is rotating about y-axis with an angular velocity of omega. Then at the instant shown, so here you can see that this metallic wire is rotating about y-axis, and we have to answer the question just for this particular instant, and this is the instant when PQ branch is parallel to x-axis. As we know that there is a concept of motional EMF. Let me quickly revise it for you, that in case of motional EMF, what is the situation? That suppose here it is one magnetic field pointing inward and here it is a rod, and this rod of length say L is moving perpendicular to its length with a velocity v. The condition is here that length, velocity and magnetic field B, all these three things are mutually perpendicular. In that case, potential difference generated across the length of the rod will be BVL. But note that these three things must be perpendicular to each other. Alright, in case if it is not, then we'll look for the component. If mutually perpendicular components exist, then in this formula we may use those components. So here you can see that in this portion PQ, at this particular instant, the portion PQ is parallel to x-axis, means PQ is parallel to magnetic field, B. So at this instant, no EMF can be developed across the PQ. And as far as the QR is concerned, you can see that when it is rotating about the y-axis, then at this instant, the velocity of this portion QR must be inward. It is going inward with a velocity of a omega, because each and every point of this portion QR is at the same distance a from the rotational axis, which is the y-axis. So velocity of this portion QR is what? At this instant it is a omega. So potential difference developed across this QR will be equal to magnetic field B into velocity into the length. Length is A. Length of the rod is A. Each and every point of this rod QR is moving with a velocity A omega, because all the points are at the same distance. So here you can see that EMF developed is B omega A square. Okay. So now let us read out the options. The potential difference across PQ is half B not omega A square across this. No, it is not. Potential difference across PQ is B not omega A square. No, it is not, because we know that potential difference across PQ is what? 0 at this instant, because it is parallel to the magnetic field. Potential difference across QR is half B omega A square. No, this is not correct. So option D is the correct option, that for QR the potential difference is B naught omega A square. So option D has to be the correct option.